DQ, we assume it's a uniform distribution there. So my linear charge distribution should be equal to DQ D. I guess we'll make that Y. That's math people corrupted me. So DQ is equal to lambda dy. So this becomes K lambda dy over R. Cosine of theta is going to be the adjacent over the hypotenuse, which is going to be, I'm just going to make that equal to big R. So times big R over little r. Oh, that should be squared. I hat plus. And now I'm ready to integrate. So my total electric field is going to be K lambda dy, big R on the outside, dy over R cubed I hat. And so now we just need to get it in terms of get Y and R together. Add a triangle right there. So little r squared is equal to big R squared plus Y squared. That is Y. So K lambda R integral of dy over big R squared plus Y squared to the 3x. I now have a single variable, limits of integration. Well, Y goes from -5 to 5. And at this point, you either do trig substitution or you look it up.
Big R is the constant.
Yeah, big R is 10 meters. So is there, sorry, if you want me to keep going or?
I should be there.
Okay. The other one should be a little bit simpler. I know there's going to be symmetry here, so all I really need to do is integrate one of them, the I hat or J hat. And I know the J hat and the I hat's going to have the same magnitude, and I know the direction. If these are positively charged, I know the direction is going to be in the midway through the fourth quadrant.
But you could do polar there, where you could go like pi over 2 to pi.
Yeah.
Right?
Yep.
And
Because-
your R.
Because this distance here is d, so that we take a differential of the charge. So dE is equal, and some angle theta, so it depends on which way you want to go. For some reason, I think typically books go from the vertical. Well, something like this, but it doesn't matter. What the heck, let's just do it that way. So dE K dQ over R squared, since R is a constant, made it capital R. dQ cosine negative sine theta I hat plus, no, it's going positive I hat, negative J hat, minus K dQ over big R squared cosine theta J hat. And it's sine and cosine are switched from what we have over there because I chose a different angle. I chose it first the vertical instead of the horizontal. I'm only going to solve one of them. So E sub x is equal to K over R squared dQ sine theta I hat. dQ is going to be lambda times this arc length. So dQ is lambda times whatever that distance is, which I'll label as ds. I know that ds is going to be equal to, and this is where we get into the polar bit, arc length is equal to theta r d theta. And so when you plug that into that, and then that into that, you end up with an integral in terms of theta, and you go from 0 to pi over 2. I'm skipping some steps, but if you want me to fill those in, I'll be glad to.
Why 0 to pi over 2 and not pi over 2 to pi?
Because when I define theta based upon this right here, and so the smallest theta can be is 0 degrees. I didn't define theta from here.
Oh.
I defined it from here.
Okay, it's like that switch, okay. You're going from 0 to what?
Pi over 2.
Oh, that's the total arc length, okay.
Yep.
Then the bottom one then, for the electric field, would that be the least electric field?
Well, it's all in this, there's no canceling out in this one, so that's why I wasn't able to make a,
Oh, you gotta calculate that one too?
yeah, I think so.
Oh, okay.
So my electric field for that one is all in the I hat direction. I have DQ here, and so K comes out, DQ over R squared. DQ is lambda dy, or lambda dx, so I hat K integral lambda dy over R squared. And R, the relationship between, so that distance there is R. If that's y right there, then R would have to be 10 minus y. Because y is a negative number. I could redefine where the origin is, fix it around, but it'll end up in the same place. So, okay. Y goes from negative 10 to 0. And one of the natural law.
Wait, why are you using Y?
Oh. Would you rather I use X?
Oh, yeah, okay. It just confused me for a second.
I originally intended to do X, but then my mind got stuck in a rut. So, and then you just work it from there. And I went through it quickly. If you want me to jump back into place or keep going any place, it's open to anybody, but just speak up.
Did you finish integrating that one on top of it?
This one?
Yeah.
R, I hat, all right, so the integral of that, negative 5 to 5, I'm gonna go off memory or I'm gonna look it up.
Would you like give that in the test or?
Yes. Pardon?
Would you give that in the test, like the integral?
Oh, yeah.
As you look it up.
Yeah.
Oh, yeah.
Should be
If you-
1 for R squared, R squared plus Y squared.
So at the top of quizzes and tests,
Yeah, he gives the integrals though.
the basic structure of it.
Oh, yeah.
And Paul, did you just say what it was?
Also misremembering, it should be Y over R squared square root of R squared plus Y squared.
Yeah, that's right.
That's on, so y over r squared square root of y squared plus r squared?
Yes.
Okay. So that r is gonna cancel out with one of those.
Just plug it in.
I, K, lambda. Over r. 5 over the square root of 5 squared plus 10 squared, minus negative 5 over the square root of negative 5 squared plus 10 squared. Please actually give an answer in the end, don't just leave it like that. Don't forget the lambda is going to be the linear charge density, which we assume is distributed evenly. And so the linear charge density is the total charge, which presumably is given,
Yeah,
divided by the 10 meters.
okay. multiple choice?
I don't know yet.
You don't have any questions?
Probably the best advice ever given to me about test writing came from Ms. Sawson, and she said, once you think it's the right length, take a problem out. So, when I start with whatever test is gonna be my base, if it's one of the earlier ones, after I've modified it, probably need to take a problem out, so. Then there's that debate over how strong is this class, do they do it? Yeah, this class can do it, yeah, they know their stuff.
Well, I guess technically, if you have more questions, then you have more points available, so you can.
Yeah, but then you also have more time.
There's also more points to lose.
Yeah.
Well, the more questions, my original attitude was, the more questions there are, the more chance you have of showing what you know.
Yeah.
But, at some point,
You might not know one that's on there, but if you have more options, then you might know that one.
That's good.
I don't know.
unfortunately, that doesn't seem to go over well with most students, that when they're actually sitting there facing it and they're realizing, it's 3 hours and I've done 2 problems.
Do you have time for another? If you
Yeah.
Teach? No.
I will answer questions that are done and then I'll move on with what we were doing.
Number 6 on this one, this is just another line of charge problem, but, because it gives like X and Y components, do we break them? into-
Oh. Yeah. This
Just
is
another one of
This is an
the-
online. I would not subject you to that because you have the line of charges running like that, and I'm asking for the electric field, I think, at this point. Now, the nicest way, if you know how to do it, is you rotate the reference frame so that it's now a vertical line and it points over here. And I do recall, I did have one student who did that.
But theoretically, you could do the normal line of charge formula, but then break it into components first and integrate each component? Is that how you would do it? You don't have to go through it, I'm just curious.
You would, in essence, yes, there's some subtlety in the language that you're using that I'm not 100% sure
Not
that.
break into components first?
You pick us a point right there, and so that would be your R, that's your right angle. So you basically treat it the same way. The difference is that you can figure out what that set distance is using geometry and algebra. This is gonna be some combination of X and Y. So you're basically gonna have a square root with X and Y in it, as opposed to just an X or just a Y.
Oh, fine. Yeah, another equal problem, okay.
Yeah, yeah.
Okay, well, we don't need to do that.
That's just for fun, you can.
Just for fun.
Yeah. Because students and faculty all have unlimited time, don't they?
I don't think that I specifically have any other questions at the moment.
Okay.
Yeah, you can just go forward. That's anything else that I.
Anyone else with a question? The fact that that doesn't erase it particularly well is a little bit nostalgic for when physics was in Ardmore. At various times, the board was just such horrible shape in Ardmore, and at various times, you'd have students when they're filling out the course evaluation say, everybody, put down they need new boards in here. And I put in a request for it several years, and it finally happened when my supervisor came to do a classroom observation. He said, we need new boards.
The electric field, Q over, 1/4 pi epsilon naught Q R squared formula.
Uh-huh.
Q R squared. So 1/4 0.045 epsilon naught is K.
Yes.
Right, okay. And then Q over R squared, that can be for any electric field problem, or if it's
Yeah.
dq, it's in the integral, it's any electric field
Right.
problem.
It's some sort of Coulomb.
But Q over R squared is the finite line of charge?
Even infinite line would be. I mean, if you actually just wanna plug a chug,
Yeah, I mean.
if you wanna just plug a chug into a Q over R squared times some constant, that is for a point charge.
Point charge, but if you have the integral in there, it can be for any electric field problem.
Yeah, yeah.
You know, what's the Q over R cube? R.
Q over R cubed, isn't that the electric dipole? Okay. O times little r. That is the electric, if I have a dielectric with a uniform charge density, so they're not all in the outer shell, they're spread throughout. That is the formula for the electric field inside.
Oh, okay. And then it's only zero, the electric field's only zero inside when it's a conductor.
Right, in electrostatic
In
equilibrium,
electrostatic equilibrium.
or at the very center of a dielectric with uniform charge distribution.
Because the fact that it's a dielectric means that the charge would be evenly distributed, but it wouldn't be necessarily the negatives and positives in the same,
It would
like
be-
in even places or whatever.
If it's an dielectric, it's an insulator, so where you fix the charges someplace and that's where they're staying. And I could just call it an insulator, but dielectric sounds so much more pompous.
Sad to forget that dielectric means
Yep. Treat them interchangeably, especially in this course. Although later on, I can't think of where they would differ. Okay, anything else? Oh, what do you want to do? So we got half hour. That's right, we should be able to finish a couple chapters.